Hi, this is Ryan, and I'm going to be providing a quick recap of Red Hat's OpenShift demos from ContainerCamp 2016 in San Francisco. You can find these slides, demos, and more at bit.ly/from-containercamp. We'll start with a quick introduction to OpenShift, then cover building and deploying Docker images, iterating on container-based solutions, replication and healing with Kubernetes, and finally, composing multi-service solutions using templates. OpenShift v3 has been rewritten to use Docker for its container runtime and Kubernetes for container lifecycle management. OpenShift extends Kubernetes to provide multi-tenant security models, advanced web console support, and developer workflows for quickly iterating on container-based solutions. First, let's see how easy it is to build and deploy a project using Docker. OpenShift provides a variety of build strategies, from Docker build to source build. It's also possible to run your builds externally and push the resulting images into the integrated Docker registry. Here, I'll be using source to image to layer my repository code on top of an operationally maintained base image. I'll go to the web console and click on Add to Project to get started. Red Hat provides a library of base images that can be extended and maintained by operations teams. I'd like to deploy a JavaScript project, so I'm going to select the Node.js base image. I'll pick a name for this new web service and provide a repository URL. Advanced routing, build, and deployment options are also available. I'll click Create to run a build and deploy the resulting Docker image. This process creates several objects in the Kubernetes API that are automatically reflected on our web console. Let's view the logs to watch the build as it happens. The OpenShift web console makes it easy for developers to review their build logs and runtime logs to provide valuable feedback early on in the release process. When the resulting build is completed, we'll push the image into our integrated Docker registry and get it ready to deploy out to Kubernetes. Here's our host name, where our resulting app will become available. Looks like the deployment is in progress, and here we are scaling up to one container, or pod in Kubernetes terms. Here's our example application deployed and ready for review. We'll also be able to pull container statuses from the Kubernetes API. OpenShift maintains a pretty close compatibility with the core Kubernetes tools. In fact, I could use the kubectl command to get my container statuses, and the output should match on the command line on the API. And our web interface uses the Kubernetes API to update the activity of the cluster as you iterate. Here's an example of how you can iterate on containers without actually making a commit. Since we've deployed a hosted container environment and we have a container up and ready, I'll use my local repository to make a small change, and then we'll copy that modification into our hosted container in order to preview our changes before making a commit. Here's the container name that I'll be, or pod name that I'll be sending my updates into. And let's refresh the page here and see if we've gotten if our updates look good. Looks good to me. This process can be automated by setting up a file watcher or by using a tool like Gulp to automatically synchronize these changes into your hosted container environment. I've included an example Gulp file so you can try setting up this automation on your own. I'll make another small change to our index file so we can verify that this process is working. I'll test this by adding 2 exclamation points to the end of our title here. Looks like they're available. I now have an easy process for iterating on Docker-based solutions that doesn't require me to stop and make a commit in order to get feedback on my solution. One more example of how you might interact with a hosted container environment. OpenShift provides a terminal web-based terminal to interact with your containers. We could see our list of processes running in this container. OpenShift also runs every container as a random user ID for increased security. The same command line access is also available through the Docker exec style command. Here I'll be running OC exec with an interactive terminal connecting to our hosted pod or container in this case, and running a bash command. So you could see the same output I was able to get from the web console is also available through command line interaction. Since we're happy with our local commits here, I'm going to set up a webhook in order to push these changes through GitHub and back into our OpenShift environment. Let's add a webhook here. I'll need to copy the payload information, the webhook payload information from my OpenShift environment. Let's find that here in our builds section. We'll check the configuration for this build and find a webhook link. And I'll copy this information into GitHub's web interface. We could also use GitHub Enterprise, Bitbucket, or a variety of other web-based revision control systems. You might also send a webhook into your Jenkins environment to run continuous integrations there as well. So I'll add and commit my changes here, and we'll see if we can trigger a new build via this webhook integration. I've committed my changes. I'll push the results into GitHub. Let's see if our changes show up here. I have 9 commits. Looks like I've got 10 now. GitHub has picked up my changes. Looks like here we have a new build up and running. I could view those logs, but instead I'm going to look at the current container state so we could watch that change. Here's before the rebuild, and if I refresh, here's our rebuilt content. Really quick for me to set up a webhook, rebuild a container based on changes, and then have a URL that I could share with the integration, continuous integration system or with coworkers. I can also kick off builds from the command line or from the web interface as well. Another way to update these hosted containers is by setting environment variables in order to provide configuration keys or other runtime details for your image-based container environments. So I'll set a key here, hello equals world, and we'll go into our web-based console and interact with the container, see if we can pull out this configuration detail. Looks like it worked. OpenShift keeps track of all your logs and feeds them into a centralized log aggregation system, making everything easy to query. Here's some more examples of how Kubernetes comes into play with replication and with auto-healing of your cluster. Here's a replication controller. This is a standard Kubernetes object that OpenShift makes use of. I can edit the spec here and change our replica size to 3 using the OC edit command. As you can see, the changes were applied immediately. There's a safer way to make these changes here. I could also use the OC scale command so I don't have to manually edit these JSON or YAML files. I'll reset the scale to 4 so we could get a little bigger cluster size here in order to see the auto scaling or auto recovery effects. So let's get a list of pods, and then we can manually cause some service disruptions by deleting some pods in our environment. Here's our list of containers. It looks like we have 4 that were used for builds, which have completed, and 4 that are currently running. I'm going to delete 3 of these, and we could watch the WebSocket feed to the OpenShift console automatically reflect the changes throughout the cluster. You can see Kubernetes was able to recover right away and get us back up to our full allocation, requested allocation of 4 pods. OpenShift also gives you really advanced tools for composing multi-service web applications. You can deploy images directly from an image on Docker Hub or from other sources. You can also build from a local source repo or from a Docker file. Or, like I showed with source to image, layer repo code onto an operationally maintained base image. Here is the resulting Kubernetes object structure that the new app command will output. The OC new app command normally sends the resulting generated object structure directly to the Kubernetes API. Here I've used the -o flag to display this information on our standard output instead. We can also use the OC create command to pass this object structure directly to the Kubernetes API. OpenShift also provides a nice templating system, allowing you to package multiple microservices together. These templates also include support for basic parameter injection, allowing you to configure templates for each stage of your deployment pipeline. Templates can also be used as installers to make groups of microservices easily available for users to launch on their own using our web-based interface. I'll be using this Node.js and MongoDB example to show how to create a quick launcher. Instead of running the OC new app command, I'll use OC create to install the template into my local project scope. Looks like it'll be available as Restify MongoDB Parks. I'll go to the web interface and search for this example in order to launch it. I'll be using a Node.js base image and the included repository source. We'll be running a build for the web code and using the MongoDB Docker image available on Docker Hub. The build is running here. It looks like we have all the pieces of our multi-service application example available after just 2 clicks on the web. If you're ready to give OpenShift a try, you can find our source code on the web at github.com/OpenShiftOrigin. We also have an all-in-one virtual machine available at openshift.org/VM. And if you're interested in deploying a large OpenShift cluster to a variety of different infrastructure as a service providers, take a look at our OpenShift Ansible repo. OpenShift Enterprise is also available with support from Red Hat, or sign up for OpenShift Dedicated to have Red Hat serve as your ops team. For more docs, information, and training material, check out the new workshop series from Red Hat and Google. We also have a variety of ebooks available for download, and of course these slides are available at bit.ly/from-ContainerCamp. This has been Ryan J. from the Red Hat booth at ContainerCamp 2016 in San Francisco. Thanks for following along.